In this next example, we're going to find the exact value of a trigonometric expression involving inverse trig expressions. What we have is the sine of the inverse cosine of 1/2 plus the inverse sine of 3/5. If we think of the inverse cosine of 1/2 as some angle alpha, we would have that alpha equals the inverse cosine of 1/2. We could think of the inverse sine of 3/5 as some angle beta. So we'd have beta is the inverse sine of 3/5. This means that the cosine of alpha equals 1/2. This means the sine of beta equals 3/5. What I should recognize is that now I am computing the sine of alpha plus beta. Remember the formula for the sine of alpha plus beta. It's going to be the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Therefore, in order to evaluate this expression, I need to determine the sine of alpha and the cosine of beta. How am I going to do that? Well, I can use the Pythagorean identities. For example, I can say that the sine of alpha is going to be plus or minus the square root of 1 minus the cosine of alpha. Which do I choose, the positive or the negative? Well, we go back up here and we recognize that the cosine of alpha is a positive quantity. When we made our domain restriction on the cosine function, we would say that alpha must be somewhere between 0 and pi inclusive. That is, alpha is either in the first quadrant or in the second quadrant. Because the cosine function is positive, we know alpha is in the first quadrant, and therefore I'm going to take the positive square root of 1 minus the cosine of alpha squared. So I get 1 minus 1/2 squared. So that's 4/4 minus 1/4 is the square root of 3/4. So that's the square root of 3 over 2. Now let's get the cosine of beta. Again, it's going to be plus or minus the square root of 1 minus sine squared of beta. Well, is it going to be the plus or the minus? We remember the domain restriction on the sine is going to be that beta must be between negative pi over 2 and pi over 2 inclusive. That means that beta is either in the first quadrant or in the fourth quadrant. Because my sine function is a positive quantity, I know that beta is in the first quadrant, and therefore I'm going to take the positive square root. So I have the positive square root of 1 minus 3/5 squared, or 1 minus 9/25. 25 minus 9 is 16, so I have the square root of 16 over 25, 4/5. So now I know the sine of alpha, I know the cosine of beta, I know the cosine of alpha, I know the sine of beta, so I'm going to get the following. The sine of the arc cosine of 1/2 plus the arc sine or inverse sine of 3/5 is going to equal the sine of alpha, square root of 3 over 2, times the cosine of beta, 4/5, plus cosine of alpha, 1/2, times sine of beta, 3/5. We simplify this, I get 4 root 3 plus 3 all over 10, and that result is exact.